Welcome dear students. This lecture is for class 8 and we will be referring NCERT textbook. Today we are going to learn about the types of numbers. First, in 5th standard and 6th standard we learnt natural numbers starting from 1, 2, 3 and goes up to infinity. Natural numbers sometimes can be called as counting number as well, because we count like 1, 2, 3, 4, 5, 6 and so on. We never count from 0, 1, 2, 3, 4. That is why they are called as counting numbers. Then in 6th standard we learn whole numbers. Whole numbers, when 0 is included in the natural number, when 0 is added to the set of natural number, we get the set of whole number. Set of whole number starts from 0, 1, 2, 3 and goes up to infinity. So, there is only a basic difference, a smaller difference between whole numbers and natural numbers is 0. So, whole numbers does have 0 and natural number set does not have 0. Then comes integers. So, in whole numbers, in the set of whole numbers, if we add negative integers, negative numbers, then that whole set is called as integers. Integer starts from minus infinite and goes up to plus infinite or plus infinity. So, all the positive numbers, all the negative numbers and 0, that all constitute integers, a set of integers. And we already know that the numbers which are on the right hand side of the 0 are positive numbers and numbers which are on the left hand side of 0 are negative numbers. And in any given situation, the number on the right hand side are greater than the number on the left hand side in all three sides. That does not matter if the number is positive or negative. On the number line, if the number comes on the right hand side of the given number, then that number is greater than the given number. And the number which comes on the left hand side is a smaller number. Now, we learnt these three types. Now, we are going to learn about the new type of number, that is called as rational number. As the name suggests, it will be in the form of ratio. It will be in the form of ratio, that is a fraction, that will be p upon q format, where p and q both are integers. Both can be positive, both can be negative, either one of them can be positive and other one can be negative. Okay? So, it does not matter, only q cannot be 0. But now, what are rational numbers exactly? On the number line, if I start putting these values 0, then the next number is 1 according to integers, whole numbers and natural number, integers and whole numbers. But there are infinite amount of numbers which are there between 0 and 1, which we already know, but we have not ever come across. Suppose 1 upon 2, half is exactly the midway between 0 and 1. So, half, this is p upon q format, yes, 1 is integer, 2 is integer, yes, and q is not equal to 0, that is 2 is not equal to 0. So, this is a rational number. Now, you will ask, sir, there are infinite numbers between 0 and 1. So, how to identify whether the given number is a rational or not, although it is in the p upon q format. So, many numbers are there which can be p upon q format, but still they are not rational number. Suppose there is a number like this. First, we will learn what are rational number and then we will learn what are not rational number. Its answer will be 3.333 and so on. Sir, this is a never ending number. This is a never ending number, but it is also at the same time it is recurring number. Recurring means it repeats its value, repeats its digit, not value, 3.333 and so on. So, that means 3 is repeated infinite number of times, but still this number, this decimal number can be represented as a ratio format. So, any number which can be represented as a ratio format and still they are recurring, they are called rational number. So, one condition is they should be able to, we should be able to represent it in the ratio format, and number 2, if it is never ending, it has to be recurring. For example, very famous number 22/7, which we know as pi, it is 3.14 and so on. It is a never ending number. It is a never ending number, but it is not recurring. The digits are repeated but randomly, not in a particular pattern. For example, sometimes you may get number like this 6.676767. This is also a never ending number, but still the digits are repeated in a particular pattern, that is after 2 digits the same 2 digits are repeated 676767 and so on. So, still this is a rational number, although it is never ending. If it is a never ending number, it has to be recurring, otherwise any decimal number, no matter how many digits are there after the decimal, it can be accounted as a rational number. 10/3, this is a never ending number. 6.676767, that is also a rational a never ending number, but these both are recurring number, that's why they are rational number, and this is not a rational number because it is never ending, true, but it is not recurring. Same way √2. So, what do you call these numbers which are not rational numbers? They are called irrational numbers. Which you will learn in detail in 9th standard. Right now in this chapter we will learn how to represent a rational number on the number line, and we will go through the properties of rational number. Now we will see the commutative and associative property for natural number. What is commutative property? Commutative is nothing but if there are two numbers, right now we are learning about natural numbers, so let us say A and B are two natural numbers. So, if I add them A plus B and B plus A, if both the answers are same, that means the order, if order does not matter, then it is commutative, that it does follow commutative property for addition. So, let us check for different operations for addition, subtraction, multiplication and division, and for commutative and associative. What is associative? Associative property is if there are three numbers, let us say A, B and C, if I group them in different order and still the answer remains same, that means it does follow associative property. Now, right now we are looking at natural number for addition, commutative and associative property. Let us check for addition. Obviously, we will check with numbers directly. 5 plus 3 equals to 3 plus 5. Yes, it is true. So, it does follow commutative property. Now, let us say associative. 1 plus 2 plus 3 will be as good as 2 plus 3 plus 1 and 1 plus 3 plus 2. Answer will be same for all the process. So, it does follow associative property for addition. So, natural number follows commutative property for addition, natural number follows associative property for addition. Let us check for subtraction now. If I do 5 minus 2, answer will be 3. But what if I do 2 minus 5? Answer will be negative minus 3, which is not a natural number, yes, and answers are not same, so it does not follow commutative property for subtraction. Same way it cannot follow associative as well. Let us check for multiplication. If I do 3 2s are, or if I do 2 3s are, will it matter? Answer will be 6 for both the cases. So natural number does follow commutative property for multiplication, and it does follow associative property as well. In division, what do you think will happen? Suppose if I do 6 divided by 2, answer will be 3. But what if I do 2 divided by 6? Will the answer be same? No. Answer will be different, and this is not also a natural number. So it does not follow commutative as well as associative property for division. Now let us check for whole numbers. We will substitute, or we will replace some of the digits to check. Now let us check for whole numbers. We will replace a few digits to check. We will include 0 in it. So if I do 5 plus 0, or if I do 0 plus 5, answer will be same, yes. So it does follow. Same way, these are all already. So whichever property is followed by natural number is followed by whole number by default. So we don't need to check separately for each and every process. We can directly jump to integers. Now in integers there is a little bit difference. It's quite same, 90% is same. If I do 6 plus 5 or 5 plus 6, answer is same. Both the answers will be integer and both will be same. Same way it will follow associative property. Now in subtraction, let's take two numbers, 2 and minus 3. Okay, I have to take a negative number as well. This number with a sign, 3 with a sign, can be considered as an integer. Okay, we cannot say that 3 is the integer and minus is the process, because minus is the sign which is there with 3 already. So if I do 2 minus 3 or if I do 3 minus 2, answer will be same? No. Here answer will be minus 1, here answer will be plus 1. Both are integers, yes, but both are not same, not equal to, that's why it does not follow commutative property or associative property for subtraction as well. Same way it will follow if I take a negative number also. If I do 3 into minus 2 or minus 2 into 3, answer will be minus 6 in both the case. Same way it will follow associative property for multiplication as well, and same way it does not follow division. So for all these three numbers, that is natural number, whole number and integers, the commutative and associative properties are followed by addition and multiplication. It is not followed by division. Understood? Now let us check. Let us go further and check for rational number. Now while adding the rational number, you have to keep in mind, you have already learnt about addition and subtraction, multiplication and division of a fraction. It is same, nothing but the same process while adding, subtracting or multiplicating or dividing. Let's jump to the addition and subtraction of rational numbers, and we can check the properties, these properties later on. Actually they are same, we don't also need to check, but still we will. While adding or subtracting, you have to keep in mind for rational numbers, for rational number or fraction or ratio, the denominator has to be same, should be same. If they are not same, we will make them same either by taking LCM. There is only one method, that is by taking LCM. Now to take LCM, there are several methods which we will learn or we have already learned. Let me take an example so the picture will be more clear. Suppose if this is the addition and subtract, this can be called as sum of the numbers, sum, SUM, sum. Now sum includes both addition and subtraction with the sign. Here there is a negative sign, so I cannot say that it is not a sum. It is still a sum, but it is a subtraction. Now all the denominators are different, so either we can do one thing, we can find the LCM of these three together, or I can separately add these two and then subtract this number from the answer of these two. Understood? So we will do both the methods. Method 1, take LCM of all these three together. Now you know that LCM method, dividing, if I divide, so 3 ones are 3, here it cannot be divided by 3, so we keep it as it is, same way. And if you multiply these three numbers, answer will be your LCM. Now LCM is 3 into 4 into 5, answer is 60. So LCM of 3, 4 and 5 is 60. So we have to make all the denominators 60. Now in ratio or in fraction, you had already learned that whatever operation, that is multiplication or division, either of these two operations, if you do any operations in the denominator, you have to do the same operation in the numerator so as not to change the value of the fraction. Now by which number I have to multiply 3 so that it will be converted into 60. So out of, there is a little trick, 3, 4 and 5, out of these three numbers, 60 is the multiplication of 3 into 4 into 5. So 3 is already there, so remaining numbers are 4 and 5. So multiplication of 4 and 5 is 20, so that will be 60. You don't need to do rough work separately, you can do it here, you can solve it in your mind. If I multiply the denominator by 20, I have to multiply the numerator by 20 also. Same way for 4, except for 4, 3 and 5 numbers 3 and 5 are there. 3 5 is 15, so I have to multiply the denominator by 15, at the same time the numerator. Same way 3 4s are 12, 5 into 12 to 12. This gives me 40, 60, 60, 75, 36. Now the denominators are same, so I can take one common denominator, 40 plus 75 minus 36. So 40 plus 75 gives you 5, 7 plus 4, 11, 115 minus 36 divided by 60. 9, this gives you 10 minus 3, 7. 79 upon 60. This is your answer. Now let's do method 2, and while doing method 2 I will also explain you the cross multiplication method to find LCM, so that you don't need to do the rough work every time you do. 2 upon 3 plus 5 upon 4 minus 3 upon 5. This is method 2. Here for cross multiplication we will group any two fractions or any two rational numbers. First we will do this for these two, you can do for these two also. For these two, what we will do is we will cross multiply. So I will multiply the 4 with 2, 3 with 5, and in the denominator this will be the numerator, and in the middle whichever the sign is or whichever the sign of the multiplication gives me, I will put that sign, and in the denominator I will multiply these two. So in the numerator first I will write 4 into 2 and 5 into 3. Because there is no change of sign, because both are positive numbers, so I will put the same sign as it is, divided by 3 into 4. Minus 3 upon 5 is retained. 3 4s are 12, 4 2s are 8, 5 3s are 15. Minus 3 upon 5. 15 plus 8 gives me 23. Yes. Divided by 12 minus 3 upon 5. Now again doing the cross multiplication method, I will multiply 23 with 5, then I will multiply 12 with 3, and in the denominator I will multiply these two numbers. 23 into 5, 3 into 12, in middle sign of minus because there is no change of sign, divided by 12 into 5. 23 5s gives you 115, minus 3 12s are 36, 60. Now you remember this step, 115 minus 36, we have reached the same step. So answer is 79 upon 60. While addition or subtraction, you have to remember only one thing, that you have to make the denominators same. Now we will learn about multiplication and division in the next lecture. Till then you can solve on your own. I will put some extra questions in the link in the description box. If you have any doubts, you can ask me in the comment box. Stay home, stay safe. Thank you.